what we have here is an exponential expression that we need to simplify. And it's a little bit of an unusual one because usually x or the other unknowns are in the baseline. But this is an expression where the unknowns are all in the exponents. And what's interesting here is that we're going to do unusual things, but the rules that we're going to apply are good old well-known rules. These are just the basic rules of exponentiation, just the consequence of the definition that we learned long time ago. But we're going to apply them in a strange way, sort of backwards. So let me just point out that rule number 1 and 2 are basically the base is the same. Rule number 3 is sort of similar because there is just one base. It's just that we're exponentiating twice. And rule number 4 and 5, the base A and B are not the same, but now the exponent is the same, right? We're exponentiating a product, and we can do that factor by factor. So these two groups, where the base is the same versus where the exponent is the same, will give us two different ways to simplify this expression. All right, let's see. So one way to do it is sort of the first grouping where we're going to go for the base. If you notice, there is 2 and 5, not related, but then 10 is 2 times 5. So one thing we can do using this rule right here, we're going to say that 2 times 5 to the x minus 2 is the same as 2 to the x minus 2 times 5 to the x minus 2. And now we're going to consolidate them, these expressions based on the common base. Mostly rule number 2, right? We have a division and the bases are the same, so we can do subtraction in the exponent. And then watch with the algebra, because with 2, we're going to have x plus 1 minus the entire expression x minus 2. So you need a parenthesis there. Little adventure with the distributive law. And then the same thing with the 5s. 5 to the x minus 2 minus x minus 2. And so we have 2 to the x plus 1 minus x plus 2 times 5 to the, I don't know if you notice, this is just 0 because we are subtracting something of itself. So it's just 0. And then x cancels. So what we have is 2 to the 3rd power times 5 to the 0, which is 8 times 1, which is 8. So that's one way. The other way is sort of going for the same exponent. But for that, we're going to need to do a little bit of work here. We're going to mess with this expression so that the only exponent we see inside is x. So 2 to the x plus 1 is 2 to the x times 2 to the 1. And this is unusual, but just read it right to left. 2 to the x times 2 to the 1 is 2 to the x plus 1. This is just the very basic first rule of exponents, but used unusually in this weird direction. But basically, 2 to the x is what we want, and 2 to the 1st power is just 2. So we have 2 times 2 to the x. Similarly, 5 to the x minus 2. Now we're going to use rule number 2. Rule number 2 says subtraction in the exponent means division. So we're going to say 5 to the x divided by 5 to the 2. And that's 5 to the x over 25, or 1 over 25 times 5 to the x. And then 10 to the x minus 2 is 10 to the x divided by 10 to the 2, or 10 to the x over 100, or 1 over 100 times 10 to the x. And now we can rewrite this expression as 2 times 2 to the x times 1 over 25 times 5 to the x divided by 1 over 100 times 10 to the x. And then we're just going to rearrange stuff, everything in x, everything with the x in it, and to the right, everything else to the left. We have 2 times 1 over 25 divided by 1 over 100. the numbers, and then the expressions with x in them is 2 to the x times 5 to the x over 10 to the x. And 2 to the x times 5 to the x is 10 to the x. And now there is complete cancellation. But even if they were completely different, like if it's 3 to the x over 5 to the x, we could express it as 3 over 5 to the x. So this last rule allows us to consolidate two exponential expressions like that in a division as long as the exponent is the same. But in this case, it's just complete cancellation. So what we have is 2 divided by 25 divided by 1 over 100, but to divide is to multiply by the reciprocal. And then there is a little cancellation here. So we have 2 times 4, which is also 8. It's always encouraging when we get the same answer after solving the same problem twice. Thank you for watching.